Good evening, all of you. Today we are going to see another problem. We have to find the S parameters for this two-port network. So the port 1 is here and port 2 is here. This 50 ohms is in parallel with port 1 and port 2. Assuming characteristic impedance as Z0, which is equal to 50 ohms. So first step, what we have to do is, we have to calculate S11, which is input reflection coefficient, which is gamma 1, which is equal to Z1 minus Z0 by Z1 plus Z0. So this is the formula we have to use. For this, what we have to do is, since we are viewing from here, this point, so this is in Z1. You terminate the output port with characteristic impedance Z0, which is 50 ohms. Now if you view from here, this 50 ohms and 50 ohms come in parallel. Therefore, Z1 is equal to 50 ohms parallel with 50. So this will give you 25 ohms. So Z0 we know, Z0 is 50 ohms. So Z1 is equal to, Z1 is 25 minus Z0 is 50 by Z1 plus Z0, which is 25 plus 50. So this will give you minus 25 divided by 75, that is minus 1 by 3. Okay. So S11 is equal to, if you divide, you will get 0.333 angle is 180 degree. Now if you take 20 log for this value, it will give you minus 9.551 dB angle 180 degree. Okay. So S11 is 0.333 angle 180 degree. If you convert this into decibels, that is 20 log 0.333, you will get minus 9.551 dB. Angle is 180 degree. Next, what we are going to do is, we are going to see S22. So this will become S22. Here it is gamma 2, output reflection coefficient. So the formula is Z2 minus Z0 by Z2 plus Z0. So what we are going to do here is, this Z0, port 1 is terminated with Z0, which is 50 ohms, and we are viewing from port 2, this is Z2. So if you carefully see, this is a symmetrical network. So when you view from here, 50 ohms in parallel with 50 ohms, so the effective value is 25 ohms. So S22 is gamma 2, which is Z2 minus Z0. Z2 is 25. 25 minus 50, because characteristic impedance is 50 divided by Z2 plus Z0, which is 25 minus 50 divided by 25 plus 50, you will get the same value. Here it is S22. So S11 and S22 both are same because it's a symmetrical network. Next we have to find out S21. next step will be S21. So to find S21, what we do is we connect a voltage source which is 2V1 plus and a series resistance of Z0 which is 50 ohms. This is Z0. At the same time, here the output port 2 is terminated with the characteristic impedance 50 ohms. So this is the circuit you have to draw. If I say S21 means this is output. We are saying the output at port 2 and the input is given at port 1. So this will be V2 or Vout. So we can very well write it as V2 by V1 plus. See, this plus is nothing but the forward wave that is entering into the port. Minus means it is reflected from the particular port terminal. That's the meaning. So V2 by V1 plus. Okay. Now this V2 is nothing but Vout by V1 plus. All are same. So first step what we have to do is these two are in parallel and that combination will be in series with 50. So this 50-50 is in parallel. So this will give you 25 ohms. So the combined effect will be 25. That 25 is in series with 50. So the total resistance ZT viewed from these 2 points will be this 50 plus 25 ohms, which is equal to 75 ohms. So from here if you see, the total impedance from this point will be this 25 plus 50 in series. Now what is the current I? So I is equal to the current from the source, which is V, 2V1 plus by the total impedance of the circuit, which is 75. Okay. So this is the current coming here. Okay. The same current I will come here. Now, actually since both are same, the current flowing here, both the impedances are same. So if I get 10 amps means here 5 amps, 5 amps. That means this current divided by 2. That will flow in the load. So current in the load, I call it this as load current. IL is equal to I divided by 2. That is 2V1 plus by 75. This divided by 2, it's nothing but this. So now 2 gets cancelled and you will be getting V1 plus by 75. Now I want the voltage here, that is V2 I want. So V2 or V0, V2 is equal to this IL multiplied by 50. So what is IL now? IL is given here, which is V1 plus by 75. V1 plus by 75 into 50. So 25 twice, 25 3 times. So V2, you bring this IL. IL is so you bring this V1 plus here. So V2 by V1 plus is equal to 2 by 3. So this is what we are expecting. That is S21 is equal to V2 by V1 plus or V out by V1 plus. The value is 2 by 3. Okay. Now 2 by 3 will give you 0.667 angle 0 degree. Okay. Now if you try to convert that into decibels, it will give you minus 3.517 dB angle 0 degree. So this is nothing but V2 by V1 plus is nothing but S21. Okay. So now we got the answer for S21, which is 0.667 angle 0, or in terms of decibels it is minus 3.517 dB. I already told you. Just take 20 log of this value, you will get this. Next we have to find out S12. For finding out S12, what we are going to do is, this load is connected to port 1, so this will be 50 ohms, and at port 2 what we are doing is a series impedance of 50 ohms, and here we will be having a source which is 2V2 plus. So now we are going to find out S12. I already told you S12 means 1 is the output, that means we are seeing the output here. So V1 or Vout, because the source is connected to the port 2. So we are seeing the output here, that is V1, and the input is given here. So S12 is nothing but output is V1 divided by V2 plus. So first what we have to do is, we have to view the impedance from the source here. Now if you see here, these two resistances are in parallel. So 50 parallel with 50 will give you 25. This 25 ohms is in series with 50. So totally from this point, from the source, the total impedance will be 50 plus 25, which is 75. You will get the same answer because it's a symmetric network. Okay. Now the current, I want the current from here, I call it as I. I is equal to V. V is 2V2 plus V by this total impedance ZT, which is 75. Okay. Now this current, here also same current, it sees two resistance of same value. That means if this is going to be 10 amps, then 5 amps will go here, 5 amps will go here. Okay. That means the current in the load is this I by 2. So I call this as IL. So IL is equal to I divided by 2, because both are same value. If it is not of same value, what you have to do is, you must apply the current division rule. Okay. Now what is I? I is 2V2 plus by 75. This value divided by 2, so into 2. This 2 and 2 gets cancelled. Now I know IL. Now what is V1? V1 is nothing but the output voltage. So V1 is equal to IL multiplied by 50. 50 ohms is the load resistance. Now IL we know, which is V2 plus by 75 multiplied by 50. You move this V2 plus this side. So V1 by V2 plus is equal to 50 by 75, which is equal to 25 twice and 25 3. Now what is V1 by V2 plus? V1 V1 by V2 plus is nothing but S12. So this is nothing but S12. So just now we found out the value for 2 by 3, which is 0.667, angle is 0 degree. If you convert this into decibels, you will be getting minus 3.517 dB decibels, angle will be 0 degree. So now we have found out S11, S22, S21 and S12. Hope you have understood this problem. It's a simple problem only to get the S parameters S11, S12, S21 and S22. Thanks for watching this video.